Good afternoon, everyone. We're going to go ahead and start into covalent bonding, and we just have a few things to go over in this first section. But we're going to start again with our learning goal, and we have a table set up in front of us. Our overall learning goal, of course, is we want to get to that level 3.0. Which is without the use of notes, students are able to differentiate between ionic and covalent bonds or compounds based on structure and basic characteristics. So we're going to look at some of the properties of covalent compounds. We're going to look at how we actually form covalent compounds, those types of things. And I just want you to go ahead and rate yourself on where you are at this point. Some of you may look at it and say, well, I have no idea what a covalent compound is or a molecular compound is, so you may put yourself at a score 1.0. That's perfectly fine, but the goal is that we'll be able to move you closer and closer towards that mastery of this skill. So let's go ahead and get started. Now, how does a covalent compound form? Now, when we looked at ionic compounds, first off, we had the actual transferring of electrons in order to be like the noble gases. Now, we're actually going to look at covalent compounds sharing those electrons to get to that same level. Regardless of whatever situation we're looking at, the goal is still to reach the octet rule. This is going to be our best friend. So we're going to get started here. There we go. Now, covalent compounds or covalent bonds are atoms held together by sharing electrons between two nonmetals. Now, for ionic, we said it was metal and nonmetal. For covalent, it is both nonmetals. So it's going to be a very limited group of elements that we're going to be working with here. But what you're going to see is we're able to make so many more complex compounds just because of the properties that they're going to exhibit. As you see here, we actually have the two nuclei, and we have the electrons being shared. These two are being shared so that each one exhibits or reaches the octet rule. So here's another diagram to show what's going on or the differences between ionic and covalent. Again, for ionic, it was actually donating away that electron coming from sodium being transferred here. We'll say this one is that one we're looking at, and we're going to get this crystal structure that forms because of it. Whereas here, we're actually going to be sharing those electrons. So both of them will be able to count them as its own, and they'll both have that stability that they desire. For a covalent bond in general, there are going to be a couple of different ways that we can look at it, or a couple of different types of bonds that we'll look at. The first one is a single bond. Now, this is going to consist of two atoms held together by sharing one pair of electrons. One pair of electrons, so two electrons are involved in this single bond. This is similar to what we see when we're dealing with hydrogen gas. Now, you notice that we see H2 written here. What's happening is each hydrogen has one valence electron, as we talked about before, and to be just like helium, it's going to share an electron between the two, giving it a stable noble gas configuration. This is what we mean by a single bond. Now, this doesn't only happen just between hydrogen and hydrogen, but this is one of the prime examples that we can use to help you understand what's going on or how we're actually sharing in those types of situations. Now, we can also have situations where there are more than just one pair of electrons that are being shared, where two or three pairs are being shared. The first one we're going to look at is a double bond, and a double bond is going to involve sharing two pairs of electrons. So single bond, one pair; double bond, two pairs. So in a double bond, we're looking at 4 electrons actually being shared here. We have 4 electrons that are being involved. This is similar to what we'll see with oxygen. When O2 forms, it actually shares 2 pairs of electrons. Now, one of the reasons why we're seeing this is, again, that stability factor. They want to be like the noble gases, but when working with another element that's also a nonmetal, this is one of the ways that we'll be able to actually proceed with that. Now, when we write a double bond, one way we can do it is using the Bohr diagrams, which is what you see here on the screen, but also we can write it as dashes. Those lines each representing a pair of electrons that's being shared. Now, the last one we're going to talk about as far as this part is going to be a triple covalent bond. Now, a triple bond shares 3 pairs of electrons, or of course 6 electrons. By now I'm hoping that you get the pattern 2, 4, 6, but we're going to keep talking about it just a little bit. Now, this is going to be in the case that we find like nitrogen. Nitrogen, when it bonds, it has 3 valence electrons that are open to make bonds. So it's going to share each of those bonds, or each of those electrons, and form what we call a triple bond. Now, this is going to be the strongest of all of our covalent bonds. It's going to be a lot of energy bound up in that bond. So we're going to actually find some interesting things we can do that, but I'll talk but I'll talk about that in class. So again, just to recap, single bonds, we have 2 pair of electrons shared. Double bond, 4 are 2 pair of electron or 4 electrons shared. And a triple bond, we're dealing with 3 pair of electrons shared. Now, if you noticed earlier, we had H2O2, and there are actually a couple other ones that fit into that same group. We call these diatomic molecules. Now, these molecules consist of 2 atoms of the same element bonded together. Now, there are 7 of them that we deal with on a regular basis. We have N2, O2, F2, Cl2, Br2, I2, and H2. The way that I remember it is, I say start at 7, so element 7 is nitrogen, and make a 7, so over to fluorine, and all the way down to iodine. And then we add hydrogen. Hydrogen, remember, is a non-metal, but it just happens to be across the periodic table because of some other properties. So start at 7, make a 7, then add hydrogen. Those will be our 7 diatomics. You want to make sure you memorize those so that you understand, and you will see them on the test, but so that you get a chance to understand a little bit more of what's going on with this unit as we continue. Now, some of the basic properties we have of molecular compounds or covalent compounds. One, they're usually going to have much lower melting points than ionic compounds, which actually means a lot of times you're going to find them in gas at room temperature. And that's the next thing we talked about, is liquid or gases at room temperature, as we're seeing here from each of these different examples. Now, this one here in the middle especially, if you've ever messed with dry ice and you put it in water, or even when you just take it out, it'll immediately start going from a solid to a gas. So this is one of the properties that we can usually look for whenever we have molecular compounds. Now, for formulas, we want to look at the formula for a molecular compound in a similar way that we did for an ionic compound. It's going to tell us how many atoms of each element are present in that molecule. So, looking at the example we have here, I have water, H2O. It has 3 total atoms, 2 of which are hydrogen, 1 is oxygen. Or what we have in the next line, which is ethene or ethylene, C2H6, 8 total atoms, 2 atoms of carbon, 6 atoms of hydrogen. Now, we've completed all the information as far as the basic properties of molecular compounds. As you should see by this point, it's not really a whole lot of information, but it's just a matter of going through and making sure you understand what's going on. I want you to rate yourself, or at least start thinking about where you are as we finish up this portion of the unit. Now, when you come into class tomorrow, we're actually going to go ahead and touch on these things and make sure you understand what's going on and how we can apply this across the board and understanding what's going on with molecular compounds. Have a good evening. I'll see you in class tomorrow.